This is question 46 on chemistry from the 2013 IMAT. So we're told that this particular molecule can be synthesized by this reaction scheme. So we have reactions 1, 2 and 3 forming these intermediate molecules, and we're asked to complete the following: whether reaction 1 and 2 are substitutions or additions, and whether reaction 3 is a reduction or a hydrolysis. So we can probably see that this will definitely be clearer if we can draw out our molecules properly. So let's look at the structures. So firstly, we've got this propene, so let's draw that. We've got the CC double bond in there. Now reaction 1, what is happening? Well, we've still got this CH2, but you can see we've got an extra bromine, an extra hydrogen, and we've lost the double bond. So let's try and keep the structure looking fairly similar and add the things that we have that are new. Then reaction 2, what's happening? Well, we can see we've got the CH3-2, which looks a bit confusing, but you can see that we've got a CH3 each end attached to the central carbon. So this just means we've got this central 3-carbon chain. Then what's happened? We've got this CN group, and what functional group is that? It can only be a nitrile with a C triple bond N, because we don't have any hydrogens on the carbon or the nitrogen. And you can see we've lost our bromine and we've kept this extra hydrogen. Then finally, reaction 3, what is happening? So we've still got this CH3-2CH central motif, but you can see that our CN has become a CH2NH2. So we put 2 hydrogens on each of these atoms. So now it should be a lot easier to class these reactions as whatever they are. So firstly, we've gone from an alkene to this bromoalkane. So what sort of reaction is this? Well, we've added 2 atoms without taking any away, which is a classic example of addition of HBr. Secondly, in reaction 2, what's happened? Well, you can see this bromine has been replaced by this cyanide group, or the nitrile group. So we've not added anything, we've just substituted this bromine with this. So this is a classic nucleophilic substitution. Then finally, reaction 3. What's happened? You can see we've broken this triple bond and we've added 2 hydrogens to each atom. So which one is it? Well, firstly, what's meant by hydrolysis? The clue's in the name, we're adding water to break a bond. And you can see that we haven't added water, we've just added hydrogen. So is it a reduction? Well, we know that hydrogen is very commonly used to reduce things because in its elemental state, hydrogen is 0, oxidation state, and when it's in a compound, it's +1. So if the hydrogen has been oxidized, then the molecule itself must have been reduced. So this is indeed a reduction with hydrogen. So that's our final answer. We've got our 3 reactions, and this corresponds to C on the question paper.